This is lesson 3.6 on perpendiculars and distance. In this lesson, we're going to talk about the distance between a point and a line and how to calculate it, and the distance between two parallel lines. So first of all, if you were trying to determine the distance from a point to a line, let's say that there's a wall and you're standing right here at that point. If we wanted to calculate how far away you are from the wall, how would we measure? Would we measure to the wall this way? Or would we measure to the wall this way? Because that certainly doesn't look like it's the same length. Or would we go this way? What would be the distance that you are from the line, from the wall? Well, it's actually defined to be the perpendicular distance from the point to that line, or from you to the wall, because the perpendicular distance is the shortest distance. So when a point is not on a line, the distance from the point to the line is the length of the segment between the point and making a right angle or perpendicular to that line. So it goes through the point and makes a right angle with the line. So you can see that shown in this diagram right here. It says given point M and segment PQ, the distance is shown there to be the perpendicular distance from M to segment PQ. So the next problem says sketch the segment that represents the distance indicated. So from point S to line PQ. So PQ is a segment in the picture, but obviously you could stretch it out and make it a line that wasn't the greatest line. Let me try that again. So if we stretch it out and make it into a line, you can see that the distance from point S to segment PQ would be that perpendicular distance right there. Okay, sketch the segment, so we don't really need this line here. We just need the perpendicular segment. The next one says sketch the segment that represents the distance from D to line AB. Well, for this one, when you go to drop a perpendicular to that opposite segment, it is helpful if you think about stretching out this segment here, because otherwise they are not going to intersect. So that segment would be the perpendicular distance from point to D to line AB. Alright, the next problem says find the distance between a point and a line. So you're given line L with the equation negative 1/3 x minus 1. So that means a y-intercept of negative 1 with a slope of negative 1 over 3. Or positive 1 back 3. So up 1 back 3. Or down 1 right 3. Okay, and there's our line. Now again, you're going to want to use a straight edge, because that was kind of terrible. You're going to want to use a straight edge because it's not easy to draw these diagrams nicely on the iPad, and you will need to be able to tell points and such on the picture. Okay, it says P has coordinates 4, 1. So 1, 2, 3, 4, up 1. There's point P. Now, we're supposed to find the distance between point P and line L. So the distance is going to be perpendicular. So what's the slope of the given line? Well, it's negative 1/3. So what's the perpendicular slope going to be? The perpendicular would be positive 3. Now, that means from point P, we're going to do a positive 3 slope to get to L. Now, if you went up 3 and right 1, obviously you're going the wrong direction. So we're going to go down 3 and left 1, and we should, if not the first time, maybe the second or third time you do the slope, you should hit a point that's on the line. That will make you feel good that you graphed it correctly. So now what we're doing is figuring out the distance between those 2 points. So we're looking for the distance between the given point, which is 4, 1, and the point we just looked, 3, negative 2. So we're doing the distance formula. We would go 4 minus 3 quantity squared. Remember, you subtract the coordinates and square them, and then you add the difference of the next one. So it would be 1 minus negative 2, or 1 plus 2. So the square root of 1 squared plus 3 squared will be the square root of 1 plus 9, which is the square root of 10. That's how far away point P is from line L. Now the next kind of problem is going to say you have two lines. X equals 8 is what kind of line? Well, X is always 8. Y can be anything. So 1, 2, 3, 4, 5, 6, 7, 8, 0, or 8, 2, or 8, negative 3, or 8, anything would be on this line. So that's going to sketch out a vertical line through 8. So x equals 8 looks like that. X equals negative 3. 1, 2, 3 will be a vertical line through negative 3. Now the distance between the lines is again the perpendicular distance. So we're just going to measure, it doesn't matter where you start, but just the horizontal distance between the two lines. And to measure it, we can just count it. So from left to right, 1, 2, 3, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You also know that this length is 8 and this length is 3. So that should make sense that the distance is 11 units. So the two lines are 11 units apart. Okay, how is the next one different? Well, y equals 2. It's not x equals this time, it's y equals. Or in other words, it could be y equals 0x plus 2. A slope of 0 means it's what kind of line? Well, it's horizontal. So through 2, you'd have a 0 slope. So you would be tracing out this line. X can be anything. Y has to be 2. So here's the line y equals 2. Then we can also graph the line y equals negative 5. So 1, 2, 3, 4, 5. And a horizontal line through negative 5 would look like that. Now, how far apart are those lines? Well, again, distance is the perpendicular distance, so we want to know that length. And it's completely arbitrary where I draw the vertical line. If two lines are parallel, their distance should be the same no matter where you are on the graph. So they should stay the same distance apart all the time. So we know that we've got 5 units down here, and we've got 2 units there, which is a distance of 7. Alright, for the next problem, we're going to have, again, a line which has a slope of negative 1 and a y-intercept of negative 2. So we're going to graph the line and then do a slope of negative 1. So down 1 over 1, down 1 over 1. This is a negative 1 slope. Or up 1, left 1, up 1, left 1, up 2, left 2. Those would all be negative 1 slopes. So here's our line, y equals negative x minus 2. Okay, and then it says P is the point 2, comma 4. So 2, comma 1, 2, 3, 4. There's our point P. This was our line L. So to find the distance, we're going to use, again, the opposite reciprocal slope of our given line because we want the perpendicular distance. So the perpendicular slope, or the slope of a perpendicular line, would be the opposite reciprocal of negative 1, which is positive 1. So if we do from P a positive 1 slope, it should hit our line at a nice point that we can tell the coordinates of. So now we're doing the distance between those 2 points to find the distance that we're looking for between the point and the line. So the distance between 2, 4 And the point where they intersected right here is at -2, 0. Distance formula, square root of the change, let me try that again, the change in the x-coordinate, square root of the difference in the x-coordinates squared, so 2 minus -2 would be 2 plus 2 squared, plus the difference in the y-coordinate squared, 4 minus 0 squared, is the square root of 4 squared plus 4 squared, which is the square root of 16 plus 16, which is the square root of 32. Now, do you remember how to break down the radical? Well, you can always do a factor tree. I see a perfect square that goes into 32, and it's 16. It goes in twice. So if you remember how to do it that way, you could do it that way as well. If you don't, then break it down like 8 and 4, 2 and 2, 2 and 4, 2 and 2. Okay, so we've got 2 pairs of 2, and the pairs come outside as one of those things. So if you have 1, 2, 3, 4, 5 2s, those guys group up and come outside as a 2. Those guys group up and come outside as a 2. And then those 2's get multiplied together. So that becomes 4 with a root 2 left over on the inside. Okay, I would like you to graph the line y equals -2x minus 5 and plot the point 0, 5 and see if you can figure out how to do the distance. Now, make sure that you do not mess up how to actually get that segment. Remember that you want, you want the, however your line looks and wherever your point is, you want the perpendicular here. You don't want to be going vertically or horizontally to the line. Okay, you want to make sure that you're using the perpendicular to the line that you graph so that it looks like that from your point to your line. Okay, so you can either pause the recording and do that problem now, or you can go and watch the next one and then come back and do that. Now, actually, the next one is the same thing that I already did with you on the previous slide. So 2 lines, you're just counting the distance on that one. But for the last one, line L has equation y equals -4. That's going to be a horizontal line through -4. And then it says the point's at -3, 6. So 1, 2, 3. 1, 2, 3, 4, 5, 6. That's our point. We're looking for the distance between the point and the line. Well, this time, the perpendicular distance would be vertical. So that one you can actually count. Whenever it's a vertical segment or a horizontal segment that you're looking for the distance of, you can count it. Otherwise, you're going to have to do the distance formula. So let's see. We've got 4 down below and 6 up above, so that should certainly be a distance of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That worked out. Distance is 10. Okay, so do these 2 problems to finish out the notes, and we'll discuss those later.